Hi everyone, my name is Eeman. I'm a doctoral researcher at Loughborough University. It's been nice to see all the presentations today with the vast scale of the projects that you're all doing. But hopefully I'll give you a little insight into something a lot smaller. So this is a research project, so it is on a small scale. But essentially my project is working on integrating GRC for the development of ultra-high performance, lightweight cementitious sandwich panel. So my project is sponsored partly by Loughborough University and partly by Specwall. And Specwall is a company that specializes in the commercial production of sandwich panels. So I'm sure you all know what a sandwich panel is. But it essentially is a composite structural element made up of 3 layers. So you have your internal insulation layer and then your 2 external structural layers. And we usually use these for curtain wall or partition wall cladding systems. So why have I chosen sandwich panels? Before we get into what I'm doing with sandwich panels, we first need to understand this question. So if we look at the productivity of the UK construction industry, it's remained fairly constant over the last 50 years. And this makes it one of the least productive industries in the UK. So although it makes up a big part of the UK economy, in terms of productivity, we are failing to achieve what we should or the potential that we have. And this means that in order to push productivity in the construction industry, we first need to be effective and efficient in the way that we are looking at construction. So this means that we need to maximize the amount we deliver from the least amount of resources. And in order to do this, we need to identify waste and eliminate that. So when we talk about waste, we talk about not only the wasted materials, but we're also talking about wasted money, wasted materials as well, wasted data, wasted public goodwill. All of that waste adds up to reduce the productivity of construction. So it all boils down to this concept of we need to start working smarter and not harder. And so sandwich panels offer this alternative to conventional construction practices because they are time-saving, they are cost-saving. We can increase the safety, we can increase all of the sustainability aspects of a typical construction method. So then you could probably ask me, well, if they're so good, why are we not already using them? And the problem is, the sandwich panels which we currently have a few shortcomings. So this is where my research comes into play, and I am looking at 3 main areas of focus. The first one is the material development. So if you remember in one of the first slides, I said that sandwich panels are used for non-load-bearing applications, and this is because of the materials that we're currently using for them. So the materials we're using limit them to non-load-bearing applications. So in order to increase the sustainable outputs, we need to move this towards a load-bearing application. And in order to do this, we need to change the materials that we're using. The second area of my study also considers the architectural feasibility. So why are we limiting a structural system from an architectural system? Why can't we combine that all in one? And so with this, we're looking at creating complex shape, curved shape panels, and with that comes the production method. So how are we going to create those curves? And the final area of my study focus is the sustainability assessment. So assessing whether it actually is as sustainable as I'm saying it's going to be. So starting with the material development, we've opted for 2 materials. So for the outer layer, we've opted for an ultra-high performance glass-reinforced concrete. So this is where I'm kind of implementing GRC into my project personally. So it's the reason we've opted for an ultra-high performance glass-reinforced concrete is to move towards that load-bearing side of things. So ultra-high performance concrete, the strengths that we're achieving are around, it says 140 there, we're now achieving around 150 megapascals with it being sprayed. And again, by increasing the strength, we've done this strategically so that we can reduce the thickness of the outer layers of the panel that we need. So by reducing the thickness, we're able to maintain the lightweight aspects of the sandwich panel, which is what it initially has. And obviously with that, because we are using UHPC, we get a very high durability properties. So I know there was a few questions about the long-term performance of UHPC earlier on. There are abundant studies, academic studies that prove the durability properties of UHPC. We've done some personally as well, so we assessed the freeze-thaw susceptibility of this material. We also did the sulfate and chloride penetration test and also water ingress test to assess whether actually they are durable long-term or not. And the results came back very positive. We'll get a bit more onto the spraying in a while, but let's move on to the core layer. So for the core layer, we've opted for a foamed concrete. So this is something that I developed as a separate project, but it is currently being sold under the Specwall, the partnering company. And the reason we opted for a foam concrete is because, again, we want to maintain the insulative properties of a sandwich panel, and we also want the two layers to be compatible with each other. So we get a lot of problems when we are trying to create a sandwich panel and the two layers are not compatible with each other in terms of failure, in terms of cracking, which is why we opted for a foam concrete. And just something to note here as well, the foam concrete is A1 fire rated. This is a big problem we have with sandwich panels, mainly because typical sandwich panels are made up of EPS or XPS foam in the core layer. So removing that EPS or XPS material, we're able to achieve those A1 fire rating panels. So moving on to the production, spraying UHPC in itself has got a lot of headache, but say that we managed to achieve a sprayable UHPC in terms of modifying the mix design, modifying the water binder ratio, modifying all the constituents of the mix, we then have another problem. So how are we going to create the curve so that it maintains its geometric stability? So UHPC, once it's sprayed, is very viscous. It will not stay within the curve that we want. And so we really have two options. We can either add an accelerator, but with that comes the headache of how are we going to apply the accelerator. We're going to reduce the workability time. And if we were to add it at the end, there's other headaches with that. The second option is we can add excessive fiber content. So if we have a very high fiber content, we can matrix the fibers to keep the mortar within place. But again, this reduces the workability. So if we look at the cast mix design, you can see that that's definitely a non-starter. So you get fiber balling, you get clumping of the fibers, and you get this constituency that's a bit like Play-Doh, and it's not something that we can actually use if we are to make the panels commercially. So this is why we opted for the GRC system, but obviously instead of the typical mix you'd use with the GRC, we are applying the UHPC mortar and then spraying the fibers at the end using the concentric spray gun system. So you can see by doing this, we're able to work towards a very workable mix design. which will help to keep that geometric stability. And these are a few old pictures which we sprayed some curves. These are 1 meter by 1 meter. So we're able to achieve double curved surfaces, single curved surfaces, and you can see the thickness of the panel which we achieved are really, really thin, which is great when we come to sandwich panels, again, because we want to maintain the lightweight nature. And the strength of these as well, even if you were try to break them, you will not be able to bend or break these panels. So in terms of the next steps of my study, that's where we've reached so far. Obviously, it's very early on in the concept stage. But the next steps of my study would be to use a flexible molding system to create these curved panels on the flexible mold so that we can reuse the mold over and over again without having to go through creating separate wooden or steel molds every time we want to make something. So the way in which we would do this is we would cast the foamed concrete onto the flexible mold system, remove this, and then spray on the UHPC. So this is the next stages of my study. And if you also remember, I also talked about a sustainability assessment. So for this, you typically would compare it to something else, so you'd have a comparative analysis. And because we're using this for load-bearing applications, the best example would be to use it to compare it to a typical brick and block work. And with that, we were able to find that actually using the sandwich panels, we were able to reduce material cost by 60%, reduce construction by 80%, and reduce the labor by almost half. In terms of the life cycle analysis, so the environmental analysis of this, we've not done this as of yet. I would anticipate that there would be greater emissions due to the high cement content in those two materials used. But what we need to consider here is, does the long-term potential pay off? So because these are very durable materials, they can withstand multiple lifespans. So whereas the typical service life for a brick and block is about 50, 60 years, with this kind of system and the materials we're using, that can withstand maybe double that. So what you need to consider is, will the emissions pay off in the long term? So essentially, my study aims to create this panel which has an all-in-one system. So it's structural load-bearing, thermal insulative, architectural feasibility of it being curved, and also it being a long-term sustainable solution. Thank you.